Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. Unstructured, simplifying NLP tasks and their data pipeline. Integration with 8 ML platforms. What is the challenge solved by Unstructured library? Okay, for that matter, let me also introduce. Unstructured is a Python library that we are going to discuss. If you are new to this series of videos that we are discussing, it might be new to you. So what is the challenge that it is solving is the raw text has to be converted to data structures actually. That is the main challenge that is solved by the Unstructured library. But why data structures? That will be the next question, right? Why it has to be in certain format? That is because of the modalities, the tasks, and the various AI models that is available today. Next question. So what is modalities? The way the AI models work, or the data, the type of the data on which the AI model works is called the modalities. Like the type of the data can be text, image, video, audio, and games. Yeah, including the games. So the games here we are talking about is the reinforced learning tasks that is taken care. But underlying all this data types, it is all numbers. Okay, so each of these data types will have different kinds of data structures, and based on that, different kinds of numerical arrays and numerical data structures will get created. On top of these modalities, we have tasks. So already you must be aware of GPT, ChatGPT, and GPT-4. You also must have experienced, some of you might have already experienced GPT-4. It can actually throw out pictures also, and it can work with text. So how it is working with multiple modalities? It is called as tasks. So what happens is the way we prompt the model, or the way we design the model itself can make it possible for it to work with multiple modalities. At the end of the day, as I told, these data, at the end of the day, whether it is image, text, video, audio, or games, it's finally going to be numbers, right? So we have to stitch the numbers together to get any of this data out so that humans can read it. That is what the entire computer science is about. Finally, the models themselves. So as you know that large language models are proliferated like crazily in last 2 to 3 months, and in the same time we have seen a lot of models coming out in vision and audio area also. We have Whisper AI, we have Segment Anything model in vision. So a lot of models are getting out there in the open. Each of these models and the platform hosting them require different data structures. You might be wondering, Kamal, why are you talking about data structures? We are just going to ask some questions to this model and it's going to throw us back the answer. So why you need to even think about data structures? See, the point here is that when you want to send your data into the large language models, because all these models, they cannot directly connect to the internet. They are just functions, plain functions that are made of neural networks, and they cannot connect to the internet until unless you actually send the data in the form that they can read. That is where unstructured comes into picture. Not just that. See, there is a concept of sending the data. You must have already come across this concept that you can actually write you can make the large language model read a PDF and ask the question from the PDF. You can make it to read the entire website. All these things, the act of sending additional data into the large language models and then working with that data is actually part of a challenge. But there is a bigger challenge actually. So when you want to model, when you want to create a new model, when you want to train a new model, you will need the text in certain format. You will need the test data in certain format. At that time also, Unstructured does a lot of support. So we are actually going one step behind the scenes of the large language models and various vision and artificial intelligence models. So that is how it is getting created. But the main concept, the main area of focus Unstructured is having is with text. So it can convert HTML to plain HTML. It can work with any kind of HTML and plain text. It can work with text PDF or image PDF. It can work with PPTs, presentations, EPUBs, emails, messages, and a lot more. And all these are from the text modality. Okay, and from inside the text, it can actually extract lots of information like IP addresses, mail IDs. We can select the part of the text based on the regular expressions. You can extract the dates. You can replace. You can clean the spaces and bullets, and you can translate between languages also. So all these things are coming packed with unstructured library. And most importantly, yeah, it actually integrates with 8 different platforms, ML platforms. So you see all these platforms are already doing various activities like HuggingFace, Argilla host a lot of models to which you can present your data, and then you can ask for the reply from the model. You will have label box, label studio, etc., which helps you to annotate the data. And we have Prodigy and Pandas, LangChain. These things help to work with the data and also move the data between your execution environment to the artificial intelligence, large language models, or any of the AI models execution environment. So all these things are done by these ML platforms. Some of these platforms can be locally stored, like HuggingFace. You can actually pull down the model locally and you can start creating the pipelines. If you see my earlier videos, I discuss about that. You can also work with label studio locally by creating a separate database, and you can annotate LangChain. I have been covering in detail about LangChain on a lot of fronts. I am covering unstructured because there is a module in LangChain which uses unstructured for reading the PDF. That is when I understood, okay, unstructured is not just about PDF reading. It has a lot more to offer. And I felt, okay, people like us who are working in this area will need unstructured library. Whether we are going to work with plain text, or whether we are going to work with AI models, or we are going to develop new AI models, this particular library will save us a lot of headache and lot of manual work. So you can automate stuff once you understand how these things work. I have already discussed about the integration, how it happens in the past, but this time we will be seeing how it is going to happen step by step. Not just with PDF alone, we will be working with various text file. I'll be going through the example that has been shared by the unstructured team. So I am not going to try anything new. So what I'm trying to do is I'm going to take their examples and I'm going to work with those examples and see how it moves. The most important point what I have seen in programming is that when you read a program, when you read a code, it feels as if you understand, but only when you run it, only when you execute it and see the data, you will realize, okay, whatever you assumed and whatever the program is doing is completely different. And this is happening because of the abstraction layer that is getting created. I'll be telling about this in a couple of minutes. As we go into Colab notebook and start discussing, I'll be sharing you this particular GitHub notebook with you guys, or the link of the video. You can take a look at that. All the code and etc. is supported by unstructured team, so I'm really glad for them. I thank them for that. I'm just sharing it and explaining to you how the data looks. So that's more important from my perspective. So that's why I'm sharing it to you guys. And I hope that you like this content. Do share it and do subscribe to my channel so that further updates related to big data, natural language processing, and artificial intelligence and Python related updates will come directly to your YouTube dashboard. Let us go to the browser right now. So this is the notebook that I was talking about. So that I will be sharing from the GitHub repo. This is the GitHub repo that you are seeing here. What we'll be, before we go into the code, I just want to highlight that if in case you are totally new to LangChain, take a look at this particular playlist in my channel, where you will get all the information related to artificial intelligence model in language models, and also reinforcement learning models like GPT-3 and GPT 3.5 and LangChain. So I cover a lot about LangChain in this playlist. With that said, let us go to the Colab environment. So the Colab environment, also it's a very simple Jupyter Notebook environment which is running virtual machine at the backend. Okay, there are certain quirks when you start working with this particular notebook. What happens is unstructured has a concept called as local inference. So what this means when it says local inference is that it pulls the model from HuggingFace or from any of the model hosting platform and keeps it locally in your environment. So this is something that we have to understand a little bit deeper, because once you try it out in your, this is a Colab environment, correct? This is not a Python script that is running. It is running in an environment that is somewhere in the cloud. But when you are going to place it inside your environment, we have to be little careful. When you install using unstructured local inference, and when you install this layout parser, after installing it, ensure that you have to restart. So even in Colab, once you install this, it will ask you to restart this particular runtime. So you have to go here and you have to say restart runtime. Don't do anything else. Don't disconnect. Don't delete the runtime. Just restart the runtime. So it will not actually remove any of the softwares that you installed. It will just restart, like how your laptop gets restarted. It just restarts it. So do the restart, then only it will work. Or else most of the applications that is going to work, that we are going to discuss, will not work. Okay, it will error out. So ensure that you restart it. So with that said, we also unstructured is not pure Python. So unstructured, what I mean, it's not pure Python. So when I say it's not pure Python, it means that it works with multiple models that is outside. It works with basic artificial intelligence AI models, and also it works with both C++ based applications that is written inside Linux, and it works with popular utils, Tesseract, OCR, etc. And it also works with Detectron 2. It is one of the models released by Facebook again, which helps in detecting the content inside the pictures, images. So it can parse the PDF data, and even if there is pictures embedded inside the PDF pages, it will still get the data out of it. I mean the text out of it. So we will see that in action in a couple of minutes. Yeah, I'll show you those examples. So this 2 steps. So you have to install LibreOffice if you are going to work with presentations. So do a pip install apt-get LibreOffice. And what I am going to do is I am going to take the examples from Unstructured IO's Git repo. So let me go and show it to you, the repo of Unstructured, so that you guys have to leave a star there. Just a minute. I hope it is visible for you guys. This is the Unstructured repo. Inside the Unstructured repo, there is something called as example-docs. So this contains all the examples that they use in their explanation and their examples in their documentation. What I am right now doing is I am pulling all this example into my execution environment, and I am so how I am going to do it, I am just going to do a git clone, and then I am going to copy the example docs folder to my local content directory. So this is the example docs, and it contains all the necessary documents. So for an example, if I double click on this, you will see that it will show me the picture that is going to get parsed. So this is the picture that will get parsed, and we'll get the data out of it. So this looks as if it's clear that it's a picture, right? It's from ArcSiv 2013 picture. This is what is the setup. So basic setup has to be completed for understanding the various steps that unstructured can do. Once you have this kind of a setup, right, you can understand any of these libraries in Python. That is the most important aspect that I have learned after understanding almost some 25 to 30 different Python libraries. That too, not just related to large language models or artificial intelligence, even related to data engineering, basics related to JSON, related to Boto3, the AWS application. Everything, if you have a setup where you can experiment with it in a free manner without thinking twice, then you can learn the Python libraries rapidly. So also that is also one of the reason why I'm using Colab notebook regularly for all of my experimentation. You can use Kaggle notebooks also, but Kaggle notebooks works on Docker. while Colab Notebook works on virtual machines. So there is a difference actually. So in case of Docker, what happens is once you restart the session, the Docker environment totally collapses. Okay, now Kaggle has changed it, but still it is little vague sometimes. But in case of Colab Notebook, it is very clear that it is given, we are given a disk space and we are given a RAM space here, and we can use it and we can restart the runtimes also. So this is more useful when it comes to working in places where especially we are going to work with local inference, we have to restart the runtime and all those stuff. So it's more easier to replicate if there is any challenge. So that is the main reason why I choose Colab. If you guys are thinking, okay, there are other options available. So that is the reason why I choose Colab. And all the content is inside the example docs, and I have given it as a name, example dir. I start by directly parsing the layout parser.pdf. So this is a PDF file. So you can take a look at that. Once you get it in your local environment, you can take a look. And this, I think I can show it to you here also. Just a minute. It will be at the bottom. I hope it will be able to render because it's a small PDF file. Usually GitHub can render the smaller files, but not the bigger files. So if it is less than in KBs, it will be able to render. So you see the PDF file here. This is the PDF file that we are parsing here. It's very simple. So we don't even need to tell that we are partitioning a PDF. So we start by partitioning. In case of unstructured, what happens is it starts by breaking the document. So it breaks the document into text. I have gone in detail about how unstructured works in my earlier video. I will attach a link of that video in this context also. However, I will just give you a background that it starts by partitioning. So it breaks the particular document into parts, and how it breaks it into parts is that every document has various elements. So document has a heading, document has various subheadings, and it has bullets. It has got text, the narrative text. So what happens is the elements are separated like that. So once you execute this and ensure that if this fails, so if it will fail if you don't follow the appropriate process. So you have to install unstructured, and then if it is asking for runtime restart, give runtime restart, or else this first command itself will fail. Okay, so if it fails, then other things will still pass, but the main intention is to work with PDF. So most of our documents are nowadays PDF. So ensure that you can properly work with PDFs. You get all these elements, and if you take a look at the first element, so you see this is the heading that you get out of it. But that's not what I am after. What I am after is to see whether it can segregate the element. So let me do a different way of checking right now. So I'm going to do a type element okay, that was a mistake. So type element lpf 0. So when I do this, so that will actually tell me what kind of element is this. So it is saying it is title element. So we know that this is the title element. Like this, it actually segregates all the elements step by step. I cannot actually, I can try something else. So instead of 0, I can say 10. So that will give me another title. So various title elements are coming out. So if I try say 23. So the narrative text. So this is a different kind of an element. So these kinds of elements are required. You will see that when it is these are required when you actually push it to the next step, when you are going to stage it. So this is the place where it is partitioning, and it is partitioning, and each of these elements will have text along with it, and you can extract the text by using string function in string instance inside the Python environment. So this is how it works. So all the I'm not going to go explain each and every particular application here. So HTML is there, presentation PPT is there, and image is there. Image is pretty important because all this, if you see, the only for partition I did not, only for PDF I did not tell anything. So I just told partition and it selected everything. It found that, okay, this is a PDF file. It found that, okay, we need to use the detectron to reduce, we have to use the detectron to do the OCR. It did everything by itself. I just called this partition function. In case of unstructured, you actually can give the complete detail also, complete function also. So if I know that I'm going to work with HTML, I can say partition HTML. And if I'm going to work with PPT, I can tell that, okay, I'm working with PPT. So it will make the life of the function little more easier. Here we are going to say we are working with the image. I showed it to you a couple of minutes back, and you see the first element is the heading. So we already saw that. And partition EPUB, I am facing some challenges. I tried installing Pandocs, but it did not work for me. I am still debugging that. Once I have some update, I will comment it out in the video. We can work with emails. So you see the point here. We can actually take the emails out of emails or presentations or whatever is there. You can take that data out. You can parse it into small chunks, and then you can load it into any of the vector stores, and then you can pass it to LangChain. This is what I have been explaining it in the earlier videos. So you can do this with all the starting from messages, emails, your Excel sheets, everything. You can do it in documentation, even Word documentations also. You can actually push it through the unstructured library and you can convert it. This is a very important task that is going to create a lot of new products out there in the market. So knowing this and working with this library is going to be very important. So hope that you guys will like this. So here you see that the element, when I am sending the email element into the unstructured partition underscore email function, I can even get the email ID of the that is inside the email. So it does a very neat job in getting all this. Okay, we will see another way also to extract the emails, but at this moment you can see that it works directly with the email file format also. And then we have the text extraction. Okay, extracting text, basic text, that is like you have this entire PDF, right? This PDF is made of text actually. And this PDF also can be written into a text file. So after you write it into a text file, that will also contain heading, that will also contain all the parts of the document. I mean, parts of the document means the heading, the subheadings, the bullets, etc. That will also still contain. You can also parse that by using partition underscore text, and you can work with the elements again. So you see that this is what we are seeing. Sometimes there are gaps inside the text which you can remove it by using group broken paragraph. I am facing challenges here. Probably it is something wrong with my setup. So you guys can try it out. And next is we have replace. So from now, this is all about cleaning. Till here, till this step, I was talking about partitioning, which means ingesting and then dividing the text. So till this cell, it is about ingesting and dividing the text. Now we have already ingested the text. Next, we are going to work on cleaning it. So how to do that? For that, there is a separate module called as cleaners, under which there are various functions like replace Unicode, and we can work with lambda function, plain lambda function that you work with in Python, that also can be used. We can, so this is what is getting used here. You can directly send regular Python functions also to the elements. It will still work because these elements are actually text elements. So they inherit the string class from string class from the Python. So you can use that also. You see that we are using the regular expressions along with Python functions here. We can actually rewrite this Python function also. So if you are new to Python, then you might be wondering, okay, what is lambda, what is text, etc. So this is basically, if you are going to write it in Python, what you will do is you will say def remove citations, and you will have an open and close bracket with text inside. So let me I know that you guys are experts, but still, if someone comes newly to this particular citations, and it will be like this. So it will be text, and what we can do is this entire activity, the activity of removing the citations will be inside this. So it will be inside here, and we will be returning it. That's it. So this is what this particular aspect is what this single line is doing. So in Python, there are lots of single liners like this. So yeah, that's one of the benefits. At the same time, it can be sometimes confusing. We have been working with Python for quite some time, so it will be very easy for us to follow. So we have seen how to work with replacing Unicodes and working with citations. Now there are functions for actually working with bullets, working with various dashes, punctuations. So I have just gone through each of these objects, methods here. The reason I am doing this is because I have to complete this before I go to the staging. So that is why I am going as per the order. So once you understand, once you can execute all these things properly, you see there are certain places where it is not executing at all. It's not executing properly because it is not considering it as bullets. It is considering it as regular text. So I am still also figuring out that how this is working. So certain places it's not working as per my expectation. So my expectation will be that if I am going to clean the bullets, A and B should not be there, right? This is what I will expect. But no, that's not how it is working. But if I use clean ordered bullets, okay, so when I use clean ordered bullets, how it works. So the point is that when you practice, you see that now when I use clean bullets, it did not work. But when I say, I give it clearly that this is an ordered bullet, remove it, then you see it is removing. So this is what I was telling to you a couple of minutes back, that when you read a particular Python code, you might feel that, okay, you understand what the code does. But once you experiment with it, like once you change a couple of things, then you will realize, okay, so this is what this function does. So whatever you are having the intuition may not actually work. That is why I insist that pulling the examples out into a place where you can experiment with like this in Colab actually changes how you learn Python libraries. And it is really fast, guys. All you have to give to learn unstructured libraries less than 3 hours. So you don't need to spend a lot of time also. But yeah, you have to practice. So as I always say that practicing is more important. You can go through all these steps. So you can extract the text based on a particular word, and you can do that same thing for email address. So you see the email address getting extracted, you see the IP address getting extracted, date times. So all these things you can see. When it goes to translating, you have to install lang detect and sentence piece. These two are required for getting the lang translate text to work. In my case, I was facing some problem with the model, so it was not working out properly. I am debugging that, but you guys also trying it out. You can try it out and see. So let me go to a PDF for a moment. As I was explaining that unstructured works on various kinds of text files and various formats of text files, and it can extract the text details, whatever details are inside the text file. So we saw these things now. Next, what we are going to do is we are going to see how to take these extracted data and push it to all these various platforms, the ML platforms. So before you guys follow on with this video, pause the video and try to give a search inside the Google for each of these names like Argilla, Datasor, HuggingFace, Labelbox, LangChain, Pandas, Prodigy. So just read out what these libraries do, what these services and libraries do. The point is, some of these libraries are pretty straightforward. You will understand, okay, like for an example, HuggingFace, you will see there are thousands of AI models getting hosted there. And it has a lot of things. It's a huge ecosystem. And when you come to LangChain, again, it is again a huge ecosystem for working with large language models. Pandas is for working with data sets like CSV format and various other files. So take a look at all these platforms out there and libraries out there and see what kind of activities they do. This is also an exercise that will give you an overview of what is going on in this particular area. So that is something that you can also try it out. Next is, how is the integration done? So right now we saw that data is ingested via partition. We had reviewed that right now, and we if you want cleaning, we can clean it. We also saw that how we can use the various functions that is already available there. Now in staging, what happens is you have already got the elements available. You saw the various types of elements like narrative text, the bullets, the headings, all those components, right? What staging does is it actually creates data structures based on these elements. It does not leave any of the details. It keeps all the details and then creates a new data structure, and then it formats it in such a way that each of these particular platform can accept it. So this is the next step that you are going to see. Let us go to the browser back, starting with Label Studio. So as you saw here, I am not all this simple stage for Label Studio. All I know is that, okay, I have to use this function and push the elements inside this. I will get the output in JSON format like this. Okay. So this is the abstraction layer that I'm talking about. As the complexity of our world increases, the functions like these starts increasing rapidly. We can always go to the GitHub repo of unstructured.io and we can understand how this particular function is written. So you can do this and you have to understand what is there, what is working below this. That will only really help you to troubleshoot if there is any problem. So I have been facing a couple of troubleshooting issues by myself. So ensure that this might look very simple, that I'm just showing you that use this function, send the elements. These elements are created from this particular text. So where is the text that we created? Just a moment. Yeah, the elements are just a minute. The elements are created from the text that we pushed in, the fake text that we pushed in. So let us take a look at the fake text that is available with us. The fake text is here. So this is the fake text that we pushed in. This is a text document. What is the address and important points? This is a very simple text that we pushed in, right? Once we send it through the function, it automatically changes and it gets ready for pushing it to Label Studio. How it does, you have to understand a bit, because there will be certain places where you have to change certain things inside the stage for Label Studio function. So be ready for that when you are developing. So this is stage for Label Studio. The output of the data looks like this. So you have the data, you have the text, and you have the reference ID. In case of Label Studio, you need to have the reference ID, and that is how you label it. So all the reference IDs are different. If you see here, it is a random number that is getting created. So you see, I am only showing the part of the output, not all the output. So if I remove this and if I show you the entire output, it will be longer actually. So yeah, the output here is not available, so that's why you are not getting it. Just a minute, let me retry it right now. So you see, this is the entire output. And this is how the elements that are created by unstructured are modified. That's what I was also talking about. So also, if you take a look at the output, let us do a type on the output. There were times when I used to think that data structures is very important. So this is a list data structure, and I am going to do a checking on the single element. So what is the single element made of? And single element is made of dictionary. So when I actually stage it to the Label Studio, it has to be made into dictionary that is in certain format. So you saw that data structure is converted, right? And here you can see there is one more way to convert to dictionary also. So if I execute this, you will see that it gets converted to dictionary like this. So you see the element, you see the coordinates. There is no coordinates actually. There are certain places where you might need the coordinates, because when you're working with images, this might actually come in handy. And why you will be needing the coordinates? There are a couple of AI models which will want to know how the image is actually, or where in the image this particular text is located. So this particular conversion does not give you the coordinates. So when you are working on it, do explore and see how to get the coordinates. That is also one of the point. And you see the type of the text available here, and this is from convert to dict. And also we can convert it to elements back. So once you convert to dict, you can convert it back also. and we can convert it to CSV file. So the CSV docker, CSV element like this, you see that it's comma separated values, and you can also convert it to data frames. This is the, this becomes pandas data frame. That's what I was telling, that you can interface with the pandas also. Now you see how it looks. So you have the type, you have the text, you have the element ID, and all these are NaN values, and you can start analyzing it directly. That is the power, guys. This is what I was trying to say. You get a text, you start analyzing it just by converting into pandas data frame. And you might want this. You might want this particular step. And right now you might be doing it in a laborious fashion, which may not be required. And so for an example, you might you might want to understand a particular document that is given to you, and you want to analyze the document in a different format. So at that time, this kinds of modification will be very useful for you. The next step that you are going to use is going to involve transformers, sentence transformers, and HuggingFace models. So for that, you need to install all these 3 libraries. Ensure that you install it, and then we are going to work with the HuggingFace internal testing TinyBird model. So this model is used for tokenizing as well as model classification. We can get the entities from this model. If you are new to what is entities are basically the grammar that is inside the English language can be detected from the text. So for an example, if you want to know this Florida panhandle, so Florida panhandle, whether it is a place or whether it is a whether it is a product or whether it's a name. So based on this context, this particular entity will get created. So this entire text, we are going to pass it through the NER. You can do it simply using stage for transformers. You convert the text as narrative text and then send it to tokenizer. If you are not aware of tokenizer, if you are not aware of these processes that is going on, take a look at my earlier videos. I will explain these things in detail. I will also attach a couple of videos that work on tokenizers, embedding, etc. You will get an idea about that. But once I complete this, let me execute this so that you guys can understand. So I'm executing the pip install. So the pip install will complete, and you see the requirement is already getting satisfied because I already installed this before I started the video. And I am doing the tokenizing. I am initiating the model. So the model is getting pulled to the local environment. So this is the model that is getting pulled, and this is the tokenizer model that is getting pulled. And now I am going to assign this text to this text variable, Python variable. And after that, I am going to stage it to the transformers, and I am going to create the chunks. So before we go to the next step, I want you guys to take a look at the chunks. See, data structures need not be tough. Data structures can be extremely easy if you can take a look at the data. How the data is arranged inside the list will actually give you a lot of information. So we already know once we send it through the stage for transformers, it is going to get converted into list. So once we convert it into list, then we can actually see each and every list. We can see it separately. Each and every element of the list, we can see it separately. And this chunk is what we are going to send it through this NLP tokenizer. So tokenizer, as well as this is a pipeline basically. This is HuggingFace. This is transformers pipeline, which takes the model, which takes the tokenizer, and then it takes this task. So in the beginning, I was explaining to you that there are models. So let me go to the presentation for a moment because it's important right now. I was discussing about the modalities, discussing about the tasks and models, correct? So the pipeline that you saw there has the task that is named entity recognition is the task. The modality is text because we are using tokenization and as well as text models. And the models that we are using is the BERT model that you saw there. Going back to the browser, this is what I was talking about. So the pipeline has been made very simple. See, pipeline is already simple, so they have already abstracted a lot of things. If you guys really want to understand what is auto tokenizer, what is auto model token classification, there is a separate, it's a separate activity altogether. You have to go to transformers library and try to understand that. Here, what they have done is they have completely abstracted the concept. So even if you don't know anything about transformers, all you know is that, okay, I know the task, I know the model name, and I know the tokenizer to use. Then you can go ahead and you can start working on that. That is the level of abstraction that has been taken care in Unstructured library. So I'm going to send it through the results, and I can show you the results in a moment. And the result will have, the entity name, and it will have the word, and also it will have the index. What is the index? So index is the number of the token, and it will also show where the index starts and ends. All these things you can actually review that, and this is a very important task inside the NLP process. So that we saw with HuggingFace, and the same way you can upload to Label Studio. So for Label Studio, it looks like this. So as I already shown at the top, and for Datasor, it is just purely text with entities. So if you are going to use it with named entities, then the entities will come here. So you can try it out. So for Datasor, you have to use the same format. And for Argilla, you can just introduce, I'm going to explain this for Argilla, and then I can show it to you how it works. In Argilla also, you will have the similar kind of a data set, but it is more involved. In case of rest of the data set, it was all in a certain format. It was in JSON format, but here you see it is in pure text format, right? And Argilla dataset requires it that way. So as we have seen from the beginning to the end, that currently, so we have seen how to completely do the activity of converting the text to text, partition it, extract the data, and then stage it to multiple platforms here. And you also saw that there are so many platforms. So in fact, when I was working for LangChain, I did not know that, okay, there are these many platforms. I knew about HuggingFace, I knew about Pandas, but once I came to know about Unstructured, then my vision, my visibility increased rapidly. So it is one of the best things that I came across. And that is also the main reason, I'm sharing this detailed video with you guys. I hope that you like this video, and do leave a share, do share it with others, and subscribe to my channel so that you can get further updates to your YouTube dashboard directly. With this, guys, I would like to take the leave as usual with 4 words: practice, 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 practice. See you then.